Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. So you can recall that in the last 3 lectures we had talked about the frequency distribution. Why we did it? Because whenever the data is coming to us, it's a raw data and we want to compile it. We want to put it in the format by which we can understand it. And I can understand what is the type of information which is contained inside it. And that we tried our best to understand through the concept of frequency distributions. Now, from this lecture, I am going to start the graphical tools. There are various types of graphical tools which are the part of exploratory data analysis and which helps us in understanding the information contained inside the data. So there are various types of these graphics, one dimensional, 2-dimensional, 3-dimensional, and there are different packages which can do it. So because of the limitation of the time here, I will try to discuss these graphical tools in 2 modes. One, using the commands which are available in the base package, and secondly, I will be considering one package which is called as ggplot. So ggplot is a very important and very useful package which can create a variety of graphics. So from this lecture and in the next couple of lectures, we will be discussing about various types of graphical tools, and we will try to take several examples to understand them, how we are going to implement them. One thing I can tell you, this R software has a tremendous capability to create very nice graphics. And the best part is that all the graphics are in your control. Your control means that if you want to change any look, any aspect, any parameter, everything is in your control. In this course or in this lecture or in the forthcoming lecture, I will be taking here some important parameters which are required to create useful and informative graphics. But beyond that also there are many aspects which can be controlled by different parameters which are available inside the same command. So for that, my request will be that whatsoever command I am going to use here, please understand them, but please try to look into the help menu also. You can see that you can control each and every aspect of the graphics. So with this objective, let us begin our lecture. So if I try to say, why should we use the graphical tools? And I can tell you that there are 2 types of tools, which one are graphical tool and say another are analytical tools. Both try to summarize the information which is contained inside the data. The analytical tools, they try to summarize the data in the form of some numerical values, which we have to interpret. Similarly, the graphical tools try to summarize the data in the form of some picture, in the form of some graphics. And graphics gives us a lot of information. For example, if I say the mood of a person may be conveyed very easily by the smileys. For example, if you try to look here 3 smileys, even if I try to remove here these names which are indicating the mood of the person, still you can say that this first picture is indicating that the person is happy, and right. And similarly, if you try to see the second picture is indicating that the person is so okay, and the third picture is indicating that the person is sad. And if you try to see here, the structure of the face, that is circle, and the structure of the eyes is the same in all the 3 pictures. It is only the mouth which is changing. But just by changing a small feature in the face, you can convey lots of information. So similar is the story with our graphic also, and such graphics have an advantage that they convey the hidden information inside the data more compactly. It is very important to remember that whenever we are trying to choose a graphic for a given set of data, then the appropriate number of graphics and the choice of plots is very important for getting the correct and better statistical inferences. Actually, the reason why I am trying to say this thing is that Usually I have heard many times people say that if you try to increase the number of graphics in your analysis, then the analysis becomes better, which is actually not correct. It is something like if somebody has some health problem and the doctor gives lots of medicine, is it good? Or is it better that the doctor understand the disease and based on that the doctor gives appropriate number of medicines, right? So please, and then second aspect is this: every graphic cannot be used on every set of data. Depending on the objective, that what exactly do you want to infer from the data or what type of information you want to dig out from the data, you have to choose the appropriate graphic. So appropriate graphic and the appropriate number of graphic, both are important for a good analysis of data. When we come to statistics, there are various types of plot that we already discussed in one of the lecture. There are two-dimensional plot, three-dimensional plot, there are scatter diagrams, pie diagram, and pie diagrams are also in, say, one-dimensional, and say three-dimensional also. Then we have histogram, we have bar plot, and within bar plot also there are some subdivided bar plot, stacked bar plot, percentage bar plot, etc. We have stem and leaf plots, we have box plots, we have violin plots, we have heat maps, we have tree maps, and there is a long list. And this R software has tremendous capability. It has a very good capability to create all such graphics. It can very easily create the bar plots, pie chart, box plot, group bar, box plot, scatter plot, co-plots, histogram, normal QQ plot, heat map, tree map, violin plots, etc. There is a very long list. And there are some charts which can be created using the base package of R, and whereas there are some specialized charts which can be created by the contributed packages. And as I told you that ggplot2 is one of the very good packages which has lots of graphics inside it, right? So now I will try to take here some representative graphics to explain you, and my idea is that yes, because there is a long list of graphics, I cannot cover all the graphics over here, but I would like to try that I give you the basic idea that how to create the graphics in the R software. And for that I will try to take first some graphics which are known to you. For example, I believe that these simple graphics like bar diagrams, pie diagram, histogram, etc., you are well aware of them. So my objective is that I will try to explain you here under what type of condition these charts are prepared and how you can construct them in the R software. Because you already know them, so if you try to do it in the R software, that will give you a lot of confidence also. And once you get the confidence, then you will be able to draw different types of graphics which are available in the R software depending on your needs and requirement. So let us first discuss about the bar chart or bar diagrams. So one thing you have to keep in mind that the bar diagrams are constructed to represent the categorical data using rectangular bars, right? And it is like that we have XY axis and we try to create here these types of bars, right? And these bar diagrams, they visualize the relative or absolute frequency of observed value of a variable, and each of the category is indicated by one bar. The height of the bars, that is determined by the absolute or the relative frequency. For example, if you try to see this is the height of the bar, this is the height of the bar, and so on. So this height of each of the bar is determined by either by the absolute frequency or the relative frequency of the respective category. And this frequency is shown on the y-axis here. One thing what you have to keep in mind that the width of the bar is not important. It is immaterial and it can be arbitrary also. Right. For example, if I try to create here a bar diagram like this one. So here this width is not important, only the height is important. Sometimes people get confused with the histogram also. In the histogram, yes, the width and the height both matters, but in the bar diagram, only the height of the bar matters. But it is only for the sake of convenience and for better understanding that we prefer to make the bars of the equal width, right. So, let me try to show you here that how this bar diagrams look like and how it is constructed, and then after that how do you represent it on the bar chart. So, you can recall that when we had considered the attribute data or the categorical data, then we had created the frequency distribution in which we have defined different categories, and then we had given different frequencies, and from those frequencies we have found the relative frequencies, right. So, if you want to represent this frequency distribution graphically, then bar diagram is one of the options. So, you can see here the bar diagram will look like this. On the x-axis we have these categories A1, A2, A3 up to here AK, right. And then the frequencies or the relative frequencies, they are on the y-axis. So, for example, this frequency can be F1, this can be F2, this can be F3, this can be F4 up to here, say here somewhere here Fk, like this. And what we try to do for each category, we try to create here a bar. For example, you can see here, this is the bar of the category 1, and here this is your either frequency or the relative frequency. And similarly, if you take the category A2, then this is represented by this yellow color bar. And you can see here this area, this where I am highlighting, this is actually the width of the bars. So, you can see here I have made it of equal size because it looks beautiful and it looks convincing. It is easier to understand it rather than having the bars of unequal width, although you are free to do it. On the y-axis, either you can use the frequency or the relative frequency. For example, this is the frequency of the third bar and so on, right. You can have same colors, you can have different colors, you can control many aspects of the bar chart in the R software. For example, if you want to control the width, you can do it. If you want to control the spacing between the bars, that can also be done. If you want to control the colors of the bar, that can also be done. So, we will try to see in the R software that what are the different options and how they can be done. But this is the basic idea about the bar diagram, right. In order to create bar plot in the R software, the command here is bar plot, which can create a vertical or the horizontal bars, right. Horizontal bars means this vertical bars are given like this and the horizontal bars are given like this, right. So, those things are possible. So, here the way we use it is that we will write the bar plot, and within the parenthesis we will write the height. Height means the data or the frequency, right. If you try to recall one thing, that whenever we are trying to create here the bar plot, I told you that on the y-axis these heights, they are indicating the frequency. And how do you obtain the frequency in a frequency distribution? In case of categorical data or this attribute, you always use the command table. So, if you have got the raw data, so first you will have to use the command table. From there you will obtain the frequencies, and these frequencies are going to be plotted according to the heights of the bar, right. So, and then if you want to modify your bar plot, then you can see here there are various options. Say bar plot with your height is the data. You can control the width, you can control the space between the two bars, you can give different names to this bar, you can give the ligand test, beside, horizontal, density, angle, etc., color, border, etc., etc. You will see there is a long list of these options, right. So, this is what I meant when I told you in the beginning that you can control the different features of the graphic using these options, right. But I would request you please try to look into the help of this bar plot and try to understand what they are trying to give you. For example, in some of the cases I can say that, for example, this height, this is a vector or a matrix of values which are trying to create the plot. Width is the parameter which is controlling the bar widths. Space is similarly like this, which is trying to control the amount of space or as a fraction of the average bar width on the left side of each bar. Similarly, names.arg is another option, which is a vector of names to be plotted below each bar or the groups of bar. Similarly, legend.text, this is another vector of text which is used to construct a legend for the plot, or this is a logical indicating whether a legend should be included or not. And then there are many more options. So my request to you will be, please have a look at the help and then try to read it from there. Yes, I agree, you may not use all these parameters in all the graphics, but at least if you read it, then at least you will come to know that these are the different possibilities, and whenever you need it, you can always plot it. So whenever we want to create here a bar plot, then we have two options. Either we can create with the absolute frequency or with the relative frequency. So for example, if I write here bar plot and here x with width equal to 1 and go on, then it will give us the bar plot. But remember one thing, this x is actually going to be the frequency. So it is a better option that if x is the raw data, then we should write bar plot and inside the parenthesis table x. So this will create a bar plot with the absolute frequencies, and if you try to use table x divided by length of x, then it will compute the relative frequencies, and then if you use the bar plot over it, then this will create a bar plot with the relative frequencies. Right. So let me try to take here a very simple example to explain you how this bar plot is created. Suppose we have collected the data on 10 persons and we have classified them as graduate or non-graduate. So for graduate we are using the number 1, and for non-graduate we are using the number 2. So graduate are represented by G or 1, whereas non-graduate persons are represented by N or 2. Right. So you can see here, this is my data. The person is graduate, so I am writing here 1. The person is non-graduate, so I am writing here 2, and so on. Because you know that when you try to deal with the statistics, then unless and until you give the data in the form of numericals, the statistics will not understand it. Right. So let us try to collect this data of 1, 2, 1, 2, etc. in a data vector quali, which is something like qualification. Right. So this I am using the C command, and then I am entering here the data. So now let me try to create here this bar plot. So what I can do here, that I can write here the bar plot quali, and I get here this type of graphic. Tell me one thing, do you really wanted this? There are only 2 categories, G and N, but you are getting here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bars. Why this is happening? Actually, we made here a mistake. The mistake is that we have to use here the command table. Well, I have done it intentionally in the sense that if you are working with different types of software, in many software, there is an option that you have to give only the raw data. But I wanted to make sure that you understand that in the R software, you need the tabulated data, right? So if you try to see, if I use the command here table on quali data, then you will get here the data like gender, and category 1 has 7 people and category 2 has 3 persons, right? And then if you try to use here the command bar plot, you can see here it will come like this. So you can see here, this is your category number 1, this is category number 2, and this is here indicating the absolute frequency, which is here 7, which is corresponding to this 7. And here if you try to see, this is here 3, and this 3 is here like this. So this is more important for you to understand that how the graphics are speaking and how graphics are trying to explain you what information do they have. So in case if I hide this data of this absolute frequency data, and if I ask you to look only on this graphic, then this graphic tells me there are two categories which are indicated by category 1, category 2, and the absolute frequency of category 1 is 7 and the absolute frequency of category 2 is 3. That means there are 70% observations in category 1 and 30% observations in category 2. Right. So this type of information is given by the bar plot. Right. Now, similarly, if you want to create the same bar plot with the relative frequency, then you have to get here the values of relative frequency by table quality divided by length quality, and it will give you here the data like this. Variable is gender, category 1 has relative frequency of 0.7 and category 2 has a relative frequency of 0.3, and if you try to create the bar plot over this relative frequency, you will get here this type of graph. So you can see here that is indicating these two are the categories, category 1 and category 2. Here you can see here this is 0.7, this is the relative frequency of category 1, and similarly here you can see here this is the 0.3, which is the relative frequency of category 2, which is given here, and the relative frequency of category 1 is given here. Right. So once again, in case if I hide the information given by the frequency distribution, and if I ask you to look only in this graphic, then this graphic is trying to give a different type of information that there are two categories. Category 1 has a relative frequency 0.7 and category 2 has a relative frequency 0.3. So this indicates that there are 70% observations are belonging to category 1 and 30% observations are belonging to category 2. So if you try to see, this is the same information which was obtained by the frequency table, and the same information is now once again obtained by here the graphics, right. So now with this small example, I had given you this idea that that how are we going to interpret it, right. And let me try to first show you this on the R software so that you get a confidence, and then I will try to take some more examples to just to convince you. So you can see here this is my here data quali, and if you try to create here the table of this quali, this will come like this. Now if you try to say here plot of quali, so you can see here you will get here this type of graphics, right. So which has 10 bars. Actually every bar is indicating the observation, right, 1, 2, 1, 2 and so on, but exactly this is not correct. Actually what you wanted, you wanted the bar plot on the table quali. So you can see here now this is here the graph, right. And similarly, if you want to have it in terms of say this relative frequency, so you can see here this is table divided by length, and you can see here the graphic will remain the same, but only here the frequencies on the y-axis they will actually change. So you can see here it is not a very difficult thing to create such a bar plots in the R software. Now let me try to give you here one more example to convince you. And you see, in the data science you will always be working with very big data sets, but my objective is that if I give you the confidence that what is happening on the small data set, and if you can correlate that whatever statistical knowledge you have learned and whatsoever is being represented on the graphic, if they are matching, they are trying to convey the same information, then you can judge better, right? So suppose I'm taking here one example that there are 3 salespersons in a shop which are denoted as 1, 2 and 3. Now suppose 100 customers are coming to the shop, and one of these shopkeeper is attending the customers. So here I have given these 100 values here, which means that, for example, if I say 1, 1, so that means the first and second customers, they were attended by the salesperson 1. Then here is 2, so that means the third customer is attended by the salesperson number 2, and so on. So this data I have stored in this data vector sales per. Now I try to create here a bar plot of this sales per. So you can see here, this again I have made here a mistake. I don't need this type of bar plot, but there are 3 salespersons, so there are going to be 3 categories in which such a data should come. Right. So I try to create here the bar plot using the command table sales per, and then this here bar plot. So this will give you here this type of data. So you can see here, by looking at this data, it is not so straightforward to look that how many customers are being attended by salesperson 1, 2 or 3. But by looking at this graphic, you can see here, this is salesperson 1, salesperson 2, salesperson 3, and these are here the absolute frequencies. Right. So you can see here this frequency is something around here 28, and similarly here it is something like here 42, 43, something like this, and the category 3 is about 30. So this is giving you this idea that approximately 28 or 30 customers are attended by salesperson number 1 and 3, whereas the salesperson number 2 has attended the maximum number of customers. So this type of information you can get very easily from such bar plot by looking at the graphic. And similarly, if you try to create here the same bar plot using the relative frequency, so the same thing is coming here also. These are here the 3 salesperson 1, 2 and 3, and here on the y-axis we have here the relative frequency. You can see here this is 0.28, this is here 0.3, and this is here around say 0.4344. So you can see here the same information in terms of relative frequency, that about 28 to 30% customers are attended by each of the salesperson 1 and 3, whereas salesperson number 2 has attended the maximum number of customers. Right. Now suppose I want to give this graph more information. Right. Now gradually I will try to add different types of options to show you how you can control different parameters of this graph. So suppose I want to give here a heading like this, customers attended by salespersons. So for that, in the same command of bar plot which you have used earlier, you have to give here use here the option main, MAIN, and then equal to, within double quotes you write the title whatever you want, and you will get here the same title. So for example, here I am typing within double quotes customer attended by the salesperson, and the same thing is coming when I try to execute it on the R console. Similarly, in case if you want to suppose give here the names salesperson 1, 2, 3, SP1, SP2, SP3, or you want to give here a title on the y-axis also, and you also want to give here a title on the x-axis, then how to do it. Right. So let me try to show you here that by different parameters which are added inside the parenthesis, you can give such information to the graphic. For example, about main, that we already have understood, right? So that customer attended by this, by salesperson, this title of the chart can be given by the command main. Now, suppose if I say here, you want to give here this SP1, SP2, SP3. So for that, you have to use here the command names.arg, and within the parenthesis using the C command, you can write down here SP1, SP2, SP3, and now this SP1, SP2, SP3, all of them have to be written within the double quote because they are the text, right? And this thing you can see here, this is appearing here. Now similarly, if you want to give here the title on the x-axis, like as here I have given here salesperson. So for that you have the command here xlab. So you try to give here xlab within double quotes salesperson and sp, whatever you want to do it. And if you try to give it here, you will see here this is appearing here, right. Similarly, if you want to give here a similar title on the y-axis, like as number of customers, then you have to use the command here ylab, and within double quotes you write number of customers. So once you try to do it, this title will come here, right. And similarly, in the same graphic, if you want to change the color of the graphics, so each and everything up to this point is the same as here in this graphic, and I am only adding here one more command col, which is used to give different colors, right. So you can see here I wanted to give the colors red, green and orange to the 3 bars. So I am writing here col is equal to, using the command c as a data vector, and within the parenthesis I will write these colors, and within the double quotes. And I can tell you here that in the R software you can look into the help menu to find out that what type of colors are possible and what are the respective commands, right. So you can see here, if you try to execute here, the red color comes here in the first bar, green color comes in the second bar, and orange color comes in the third bar, right. So let me try to show you these things first on the R console, and then I will try to give you here one last example where I will not look into the data set, right. So first let me store the data of the salesperson, and now if I try to create here this bar plot of table, so you can see here it is coming here to be like this. And if you want to create the same thing in terms of the relative frequency actually here, then you can see here it will here come out to be like this. The bar plot will remain the same, only the values on the y-axis will actually change. And if you want to add here only the title here, then if you give here title, you can see here this title is here, right. And similarly, if you want to add here more options, like as title on the x-axis, y-axis, legend, etc. So if you try to use this command, you can see here now this salesperson, SP1, SP2, SP3, number of customers, they have come here. Now if you want to change the color of the bars also, then you can use here like this. So you can see here, similarly, if you try to make an exercise with the remaining parameters which are available in the help menu, then you will understand it actually very easily. And now here I have shown you the data, right? Either very small data or a reasonable data. But now I want to illustrate here an example that particularly in data science, when you are getting the data is so huge that you will have no option to look at it, but then you will simply have to use the data. So in order to illustrate it, I am just using here the same data which we have used earlier many times. I am using the data on painters from the mass library. So I upload the library here, library mass. And then if you try to see the column names of this data set painters, there were 5 variable: composition, drawing, color, expression, which were numerical, and there was a variable school which was a categorical variable, which has values A, B, C, D, E, F, G, H, and these are the schools from where to which various painters belong to. So if you try to have a look, you have this data on the school like this one. And now my objective is that I simply want to create here the bar plots. So I can find out here the table painters dollar variable, which will give me here the absolute frequencies. And then I will try to find out here the relative frequencies using the command table within parenthesis painters dollar school divided by length painters dollar school, and I get here these are the relative frequencies, right. And this is here the screenshot that you can get very easily. And if you try to see here that if I try to use the command here table painters.school and then create a bar plot, it will look like this. So now if you try to see, we haven't looked at the data, but I can see here there are categories like A, B, C, D, E, F, G, H, and from there I can see here that category A has frequency 10, category B has frequency 6, and category C also has frequency 6, category D has frequency 10. Similarly, category E has somewhere here frequency 7, category F has frequency 4, category G has frequency 7, and category H has frequency 4. So from here you can make different types of conclusion that or the maximum number of painters are coming from the schools A and D, and then the second largest number of painters are coming from the schools E and here G, and so on. Right. Now in this case, if you want to give here different type of information, so now you have understood how to give it this information. So suppose I want to give here this here title of the graph, School of Painters in Mass. So this I can do using the command main. Right. Then similarly, I wanted to give here this school names as A, B, C, D, E, F, G, H. So I am giving it using the option names.arg, and which is given over here. Right. Similarly, if I want to give here this heading on the x-axis, so this I can do by here xlab is equal to school, and similarly if I want to give label on the y-axis, this is given by here the ylab, which is number of painters, and if I want to give here the different types of these colors, then I can use here the command col, and then within as a data vector I can give the list of the colors which I want to give, say red, green, orange, pink, yellow, blue, gray, sky blue, and they will appear in the same sequence over here. So you can see here it is not a very difficult thing, and you can see this graph here very clearly. Right. Similarly, if you want to make here more changes, you can do it very easily actually. So let me try to show you these things on the R software. So first let me try to load this library, and now you see I will show you that how are we going to work. We are not going to do anything, but I will simply use here the command barplot table with the painter school, and if I try to say here like this, you can see the graphic is here. You don't need to look into the different data. And similarly, if you want to make it here a more informative graphic, I can give here the command, and you can see here this is here the command, and you can see here you can this export this graphic in different ways. You can copy it and then you can convert it to different formats. Right. So now we come to an end to this lecture, and you can see that it was a very simple lecture but very important to understand. And I have gone quite slowly in this lecture because this was the first lecture on the graphics, and I have shown you that how the graphics are going to be created and how you can control different features of the graphic which you want to have in your plot. The choice of the parameter or the choice of type of information which you want to have in your graphics, it depends on what exactly do you want, what type of information you want to infer in the graphic, because the difference is that once you have the graphic before you, then you will not look into the numerical data. So the graphic has to be created in such a way which is reflecting the same information which is contained inside my data. So this is the key where you have to concentrate. And once you have different types of graphics, then the next question will come, okay, for this type of information, which of the graphic is going to give me the more suitable information, or which type of graphic is more informative. The next question is that if you have something in your mind that this type of graphics you want, then the different types of information can be inserted in the graphic using different types of commands which are available in the R software. For that, you need to at least read the help menu once, and you need to understand it, what it is trying to say. Yes, I agree that for the first time when you are trying to do it, it will take some time. But you have to do it only once. This help menu will always be before you. If you have this idea in your mind, yeah, these are the different possibilities which I can do, then whenever you want it, you simply have to look into the help menu and try to see what is the proper command and how to give it. It is possible that in the beginning you may make some mistake, but then keep on trying. Once you get the proper command, then after that you can circulate that command to your entire office, and the people in the office will be creating the same graphic for their own data set, which will be very easy for you to compare. So I request you, please try to take a small data set and a bigger data set and try to create these bar plots. Try to experiment with different type of options which are given over there, and try to see how those options are changing the graphic when they are executed. So once you have this type of practice, you will be more comfortable in creating the graphics of the choice you want. So you try to practice it, and I will see you in the next lecture. Till then, goodbye.